Hello Sec.2, welcome to the next part of the atomic structure. Here we will see the Rutherford's atomic model. This is Rutherford. Rutherford used the apparatus in front of you by using the alpha particles to know more information about the structure of the atom. He used zinc sulfide as a metal that has a property of glowing by hitting with alpha rays, and he used a gold foil as a model of atom and a source of alpha particle, as you see in the figure in front of you. Okay, metal sheet covered with zinc sulfide. Why he used zinc sulfide? Because zinc sulfide has the ability to glow when hits with alpha rays. Okay, and he used gold foil, and the gold foil represented the atom, and he used a source of alpha particles. Let's see what happens in the experiment of Rutherford's experiment. In this figure, when he placed a gold foil in front of the alpha rays, he concluded many observations. Let's see the observations of the experiment of Rutherford. Again, he used the opposite figure that consists of metal sheet covered with zinc sulfide that has the ability of glowing by hitting the alpha particle. Okay, and put a thin gold foil between the source of alpha particles and zinc sulfide. Let's see the observation of this experiment. Rutherford observed that most of alpha particles penetrated the gold foil. And this means that the atom consists of a lot of the atom contains space. Okay, and not like Dalton and Thomson said. They said that the atom is a solid sphere. But now, in the experiment of Rutherford, he observed, number one, again, most of alpha particles penetrated the gold foil. And this means that most of the atom is space, not as explained by Dalton and Thomson, as they said that the atom is a solid sphere. Okay, this is number one of the observation. Number two, he observed a very small percentage of alpha particles reflected, returning back again. Okay, and this means that there is a small object inside the atom, and this object has high density. So by hitting the alpha particle, this object that has a high density, they will reflect back again. Okay, these are two observations. Next, number three, he observed that some alpha particles penetrated the foil but were deflected. Penetrated the foil but were deflected. Why? This means that the dense part of the atom, okay, that is concentrated in the center of the atom, that has a high density, contains or charged with positive charge. Charged with positive charge. And this is the same charge of alpha particle. The charge of the alpha particle is positive charge. And this object that has a high density and located in the center of the atom has the same charge, so the alpha rays that hit this object will deflect, as both of them have the same charge. After that, Rutherford concluded that the structure of the atom has a complicated structure, and it looks like the structure of the solar system. Okay. He concluded that the atom contains a part that is located in the center of the atom, and this part has a high density and has a positive charge, and most of the mass of the atom is concentrated in this part. This part is called the nucleus. Okay, and he said that there is a large space between the nucleus and the orbit, so most of the atom is space, and the mass of the atom and positive charge are concentrated in its nucleus. And he said that the electrons have a negligible mass to that of the nucleus. Okay, and they rotate in the orbit around the nucleus. They rotate in the orbits around the nucleus with a very high speed. Okay, then he said that the electrons revolve around the nucleus in a fixed orbit, as electrons are affected by two forces. He said that the electrons are affected by two forces. These two forces are equal in strength but opposite direction, And this is the reason by which the electrons don't attract to the nucleus, okay, or don't fall inside the nucleus. So the electrons affected by two forces equal in strength but opposite in direction. The two forces are, number one, the force of attraction force between the nucleus and the electrons, as the nucleus contains positive charge and the electrons contains contains a negative charge, so there is attraction force between a positive charge in the nucleus and negative charge in the electrons rotates around the nucleus. But there is another force that has equal in strength, but has an opposite direction to prevent the attraction between or to prevent the falling of electrons inside the nucleus. Okay, the other force is called centrifugal force. Centrifugal force, this is force appears due to the velocity of electrons around the nucleus. So the electrons are affected by two forces. They are equal in strength but in the opposite direction to prevent falling down of electrons inside the nucleus. Okay. Also, Rutherford said that the atom contains the positive charge equal to the negative charge. The positive charge that is concentrated in the nucleus equal to the negative charge that is in the electrons rotates around the nucleus. So the atom is electrically neutral. What's meant by electrically neutral? Electrically neutral means that the atom doesn't carry a charge, doesn't carry a positive charge or doesn't carry negative charge, as both of them are equal. So the atom is electrically neutral. Okay. But now pay attention. Rutherford theory of the atomic model doesn't explain the system at which electrons revolve around the nucleus. Okay, he said that there are electrons that carry negative charge, rotates around the nucleus, but he doesn't explain the system at which the electrons revolve around the nucleus. Okay, let's see, very important question. Why the electrons are not attracted to the nucleus? As we said before, that the electrons are affected by two forces. Number one, the attraction force between the nucleus and the electrons, and the opposite force that prevents the attraction between them, that is called centrifugal force. Okay, so number two, centrifugal force that appears due to the high velocity of the rotation of electrons around the nucleus. Okay, and now let's go to see a video for the Rutherford experiment for more illustration.
Rutherford's model of an atom. In this module, you will learn about Rutherford's model of an atom. A number of scientists worked on the structure of an atom. One of the first scientists was Sir J.J. Thomson, but his model could not explain the results of several experiments. One of those experiments which could not justify the Thomson model was done by Rutherford. Rutherford's experiment got popular by the name of alpha particle scattering experiment. To understand about his experiment, let us first see what alpha particles are. Alpha particles are emitted by radioactive substances. These are helium ions with double positive charge. Now let us look into the details of the alpha particle scattering experiment. The setup of the experiment consisted of a thick lead box with a hole on one of its walls, a slit, a thin gold foil, and a rotating detector at the end. Inside the lead box, a radioactive substance rich in alpha particles was kept. Now, let us see the experiment. Alpha particles emitted from the radioactive source passed through the hole and entered into the slit to get streamlined. The thin streams of the particles then bombarded the gold foil and got scattered in different directions. Their scattering pattern was shown by the detector. It was expected from the Thomson model that it should show a large number of deflections. But something else was observed actually. The detector showed that most of the alpha particles passed through the gold foil as such without showing any deflection. Only a few of them showed deflection in different directions. A very few of them, essentially 1 in 12,000, rebounded back. Such observations led to significant conclusions. Let us see what those were. As most of the particles passed undeflected, Rutherford concluded that most of the space inside a gold atom was empty. A few particles were deflected from their path by small angles, indicating that there must be a positively charged center, which was repelling alpha particles. As these particles were few in number, this led to the conclusion that a positively charged center occupies a tiny space. The few particles that are rebounded back indicate that all the positive charge of the atom was concentrated in a very small volume in the center. Rutherford named this positive center of the atom as a nucleus. Looking at the proportion of the particles undeflected, deflected, and rebounded, and based upon some calculations, Rutherford concluded that most of the mass of an atom is concentrated in its nucleus. Based on all these conclusions, Rutherford suggested an atomic model which was known as the nuclear model of atom. According to Rutherford's nuclear model, there is a positively charged center in an atom called nucleus, and all the mass of the atom is due to this nucleus. It also suggested that electrons of the atom revolve around its nucleus. This model was also known as planetary model, as the nucleus of the atom can be compared to a miniature sun, and electrons revolving around the nucleus can be compared to the planets revolving around the sun. But this model did not get much acceptance, as it said that the electron keeps revolving around the nucleus. However, later it was found that any charged body while moving in a circular motion undergoes acceleration. On undergoing acceleration, it should use some energy, so the energy of the electrons should keep decreasing. As a result, the path in which the electron is moving should keep becoming smaller, and thus, finally, it should fall into the nucleus, and hence the atom should collapse. So, the nuclear model could not explain the stability of the atom, and this was its major drawback. Let's recap. Rutherford gave a nuclear model of an atom which was based on his alpha particle scattering experiment. According to the Rutherford's model of an atom, all the positive charge and mass of an atom is concentrated at the center. The center of an atom is called the nucleus. The size of the nucleus is very small as compared to the size of the atom. The electrons of an atom revolve around the nucleus. The major drawback of this model was that it could not explain the stability of the atom.